These few examples will look at actually writing the function with the given transformations. So sometimes it's a little more difficult because of the order of operations you have to follow. So for part A, we're going to shift the function up by 2. So we have some function f of x. So in order for it to go up by 2, we have to take the function and add 2 at the end. Okay? Then the next thing it has us do is reflect it about the x-axis. Now when you do that, it makes the entire function negative. So in order to do that, we have to make this entire function negative, because it says first we shift it up by 2 and then we reflect that about the x-axis. So the it that it's talking about is the entire f of x plus 2 that we created. So in a sense, we made the function negative f of x minus 2. But you have to first shift it up by 2 and then reflect it about the x-axis. All right, for part B, part B first has us reflect it about the x-axis first. So that will make negative on the function. Remember, you have your graph, wherever your function is, your x-axis, you're changing the function values, so we'll go over the x-axis. And then, if it has you shift that up by 2, you will simply put a plus 2 on the end. There's no parentheses here to do anything with. It's just negative f of x, and then you shift that function up 2. It's a completely different function from part A. So you have to watch the order in which you do those. Right? For part C, it has us first shift the function right by 1. So anytime you go left or right, it's a change on the inside. So if we're going to go right 1, it'll be x minus 1 on the inside. And then if we reflect that function about the y-axis, a reflection on, if you recall, reflection on the y-axis actually puts a negative on the inside, but we need to put a negative on the fact that we shifted it right by 1. So we need to put a negative on that entire inside. So what that looks like is f of negative of the quantity x minus 1, which would be the same as doing negative x plus 1, if you saw it worked out distributed, but you'd have to have the negative on the outside in order to make it do that. Okay. For this next one, we're going to reflect the function about the y-axis. So if we do that, we'll have an f of negative x that will reflect it about the y-axis, and then we will shift that portion right by 1. In order to make it go right 1, we have to subtract 1. So we'll do f of negative x. Again, right 1 does minus 1 inside. So we'll do negative x minus 1, which is a different function than before. And if you were to pull the negative off of that, it would be negative x, or sorry, not negative. It would be a negative and then an x plus 1. Again, a completely different function than the one above it. Part E is going to have us stretch vertically by a factor of 2. So anytime we stretch vertically, it actually multiplies the outside by 2. So we have 2 f of x. We'll stretch it vertically by a factor of 2. And then if we shift that down 2, it'll simply subtract 2 on the outside. And that's a multiplied quantity here. There's no parentheses necessary. For the very last one, we have a shift down 2 on the function. So that'll take the function f of x and go down 2. And then, here's the tricky part to this wording. It's going to stretch that function vertically by a factor of 2. So it stretches the entire function that you just shifted down by 2. It stretches that whole thing vertically by a factor of 2. So you have to put the brackets on that whole function that you shifted down to. because it tells you to do that first and then stretch it vertically. So really, you have the function 2f of x minus 4 is what it would look like as a formula. But you have to put the 2 on the outside multiplied by that quantity in order to accurately reflect what this function would be with a transformation.